Good morning, everyone, and welcome to today's Red Hat webinar on OpenShift technical overview and key features. Let me introduce you to today's team. Rick Meggins will be the speaker and trainer for today. Dirk Davidis is here for the Q&A. Gary Williams is the Business Development Manager at Red Hat. My name is Gregory Engesser, and I'm the Account Marketing Manager at Fastlane Switzerland. I wish you a very exciting webinar, and now I hand over to Gary Williams for the housekeeping rules. Thank you.
Thank you, Gregory, and welcome to everybody joining the session. We've got a nice intimate session today, which is good. You know, the good number of attendees where we can be active on the chat. So, just to give you a bit of information and housekeeping rules, you will have been muted upon entry, and you will remain muted during the event. But we do ask as much questions as possible via our Q&A section that you'll find up on the right-hand side. There is a chat function which Rick may ask questions, and you may interact with him on those chat items with there. But if you do have questions, and Dirk is managing the Q&A section, please put them in there. And we'll obviously go through them either in real time or at the end of each section to give you those answers and have discussion around those. If there is anything unanswered, we'll address it at the last 10 minutes of each section, or even at the end of today's webinar. And this session is going to be recorded and shared with you after the event by Gregory and the team at Fastlane. So enjoy, please interact as much as possible to make the session as valuable to you as possible, and for us also, and enjoy the event. Over to you, Rick.
Okay, thank you, Gary. Hi, welcome. My name is Rick Meggins. I'm a Red Hat certified architect, instructor and examiner for Red Hat. I'm also a solution architect. With me, I have Dirk Davidis. Dirk is the same. He's an instructor, he's an architect, he's an examiner. Also solution architect, and with the two of us, we will be more than able to help you with this journey. We are going to talk about containers. We're going to talk about zero to hero, from getting your container, getting your workload from a traditional way of working all the way up to an OpenShift Kubernetes deployment. Now, to do so, I'm going to use the most minimal application I could think of, which is an Apache web server with one index page, HTML, hello world. So it's not about this application, it is about the way this application moves through time to end up as a workload on our Red Hat OpenShift cluster. So I'm going to talk about this, and I'm going to show you how this can work. It is up to you then to take this and to take the learning paths we present to you at the end of the presentation to build up your knowledge, build up your skills, and then start deploying workloads on an OpenShift Kubernetes platform. I'm not going to talk about the domain-specific knowledge you need to have to get an application onto, to shift it from traditional to OpenShift. That's way too complex, so I'm not going to touch that. So, that's what we're going to do. To do this, we need to have some common understanding here. And I'm going to ask the first question here. Please answer in chat. Who of you have been working with containers, Docker, Rocket, whatever you may think of in the past? Please type your answer in chat. Yeah, so we definitely have to talk about what happened to Docker. And we will, because it is, as you see on my calendar, one of the things I wanted to talk about. So, we have some experience with Docker and containers, that's good. Once use it or try Docker. Thank you, Martin. Yeah. Well, I hope by the end of this session, you will find yourself wanting to try it again, because if you get the gist of what a container is, it's actually quite fun. I really enjoy working with containers. I like to deliver this workshop or this webinar particularly because I like to play around with containers. So let's dig into it. First thing we need to understand is that our kernel, our Linux kernel, has no idea of the whole concept of a container. If you ask your Linux machine, hey kernel, what can you tell me about the containers we have? Your kernel will be blank like, I have no clue what you're talking about. So we have to address this. And to address this, we first have to look at how the container lives and where it comes from. So in traditional IT, I'm gray, as you may can see from the camera. I've been in this business now for over 30 years. So I started out on the left with traditional IT. I had a big box. It was one big box, and I had to put all the applications on top of it because that one big box was very, very, very expensive. So I had to put all my applications on that one box. And then if I really, really, really needed it, I could ask for a second box. And we're talking about 5-6 figures in costs. They are really, really expensive at that time. So we really needed to do, and we really needed to get a way to get that application to run on that box. But of course, if we have an application A and an application B living on the same box, the same operating system, they share the libraries. And as long as the applications play nice with each other, they can share the libraries. If that is not the case, either application A or application B will have a problem when library B gets changed. So we moved away from that motive basically and start using virtual machines. And in a virtual machine, we still had that one big, very expensive box, but now we cut out in that big box smaller machines, smaller computers with an operating system, with a virtualized hardware on it. And then we could basically do the same thing as with traditional IT. So we could land the application on that one box, but if we had a second application that needs a other version of the same library, we could move it away to another virtual machine. And this helped us to condense more applications on that one box. So the density became bigger. The third part in the evolution was to say, okay, I am going to now not make my boxes out of computers, but I'm going to make my boxes out of processes. So what we do in a container is we box everything we need for that one application into one process, basically. Now you can imagine that we are now getting to the highest density we can have on a piece of machinery when we go into these steps. Now, and this is why I say your operating system has no knowledge about the concept of a container, because it is a concept that is built together with a number of elements we will discuss later. So, a container is a process. It has a PID. However, in that container, we can run processes. And those processes then have their own PID. That container has its own PID tree. So we can have a container running with a PID outside on the host machine of 1, 2, 3, 4, 5. Inside the container, a process is running, doing something very important for you. And that process in that container has PID 0. Or 1 or 2. So there is a mapping going on there. This is all being done by the functionality we already have in our operating system in Linux since 2006. 2005, 2004, depending on where you count. So this is not the newest of technologies. We already have that capability for a long time. We are now able to use it. And the reason why we are able to use it is thanks to Docker. The friends from Docker found a way to make all that very complex low-level technology available through an interface. And that interface basically is what Docker did for us. Now, one of those complex elements is C groups, and then we have the namespaces, but we have a lot more, and the next slide will tell you a bit more about what we have here. So a container needs a runtime. It needs something to run on. A bit like a Java application needing a JVM, a bit like, it's not exactly the same, a bit like, so it needs something to run on. Now, in Docker, that thing to run on, that was Docker. So the Docker binary, which is a Go application, it's one binary, and it's the backend, and it's the front end of the same system. So your Docker executable holds an API, it exposes an API, and that helps us from the front end to create containers and to create images. On the back end, it runs the container. We made a shift to Creo and to Podman just to make a distinction between what's the part that we need at a certain point in time to create images and what's the part we need to run images, because we don't need the functionality to create an image on a machine that is only there to run containers. We don't need that functionality. So that's why we made that cut, but we will discuss it further. Let's dive into a container first. So again, a container is Linux. Yes, I know we have Windows containers. They go a bit like on the same way they try to box in that application, but when we started out, containers. What we do is to take that application and make it that it does not interfere with other applications. We box it in, and we box it in by using the concept of a namespace. And we have somewhere around 8 namespaces available. And one of those namespaces is responsible for your name, literally, the name of the container or the name of the object. So the name of your host is actually a name based on a namespace. So we can have a separate namespace for the name of the container, of the process. We can have a namespace for networking. So we box in the networking capabilities using a namespace. We box in the amount of CPU that process is able to consume by using C groups. The same goes for the memory. So using C groups, we make sure that this application will play nice alongside all the other applications, because we tell each and every application, you will only get X amount of millicores. You will only get Y amount of RAM. I know we have a gazillion gigabytes of RAM on this box, but you will only get 2 megabytes. That's the only thing you need. Now, things like seccomp and as a Linux help us to box in this application even more. So we can tell this application, this container, you as a process, you are only allowed to do this and this and this on the machine. So we don't need the container to be root unless it really needs to be root, and then we can make other provisions. So we can really box this application in here. On top of this, we have the concept of layered file system. And a layered file system is actually exactly what it says. So let's imagine we have that directory etc. And now we have a file in etc called what shall we do? myapplication.config. if I need that configuration file, my configuration.config, and I need it in the etc directory, if I put it on the layered file system, my computer will see it as one file system. So it will perceive at runtime, hey, I have a directory etc. In this directory etc. I have a file called my application config. When I take this container away, that layer, that file system layer is going away, and there is no file my application configuration anymore. That's the layered file system. I recommend you to read up on layered file system. It can seem to be very complex, but if you get the idea of it, it is so incredibly powerful. And what we do with a container is adding layers on top of the file system. And these layers we package into one big bucket, and that's the image. Now that image then can be run. Wow, that's a lot. Dirk, do we have questions already, or are people a bit?
There are no questions at all.
Not at all?
No questions at all at the moment.
Not at all. Please, if you have questions. Sorry?
I keep you updated when there are any questions.
Yes, please. And please, if I go too fast, let me know, guys, because I know this can be very daunting.
I will.
Yeah. Okay, Podman. What's Podman? Podman is a daemonless container engine for developing, managing, running OCI containers on your Linux system. Containers can run either as root or rootless. This is from the Podman.io website. I didn't create this one. So Podman is a piece of the puzzle when we want to use containers. But it's one of the pieces of the puzzles. If we go to Docker, Docker is a set of products. I see Frank. Frank, can't see you anymore. Is that intentionally? Yeah, I see my camera stopped sharing. It's not intentionally, Frank. Let's see if I can. Oh, is this better? I see myself now again. Yeah, okay. Thank you, Frank. Okay. Okay, back to Docker. Docker is a set of tools, actually. So it is that one executable, but it has many different functions. It can do the front-end stuff, it can do a Docker build, and it can do the back-end stuff, aka running the container. And this is the main difference. One-trick pony versus I can do it all. In Linux, we try to have as many one-trick ponies as possible. One executable that does one task as best as it can do. So we don't really like monoliths. Docker is a monolith. Now, this is a matter of opinion and a matter of preference, but we decided to step away from Docker, step away from that monolith, and go to the small applications that can do that one task they are set out to do perfectly, and then some other piece of software can do that other task, which is also important. So that's why we stepped away from Docker, and we now on RHEL 8 provide you with Podman. Actually, Podman, Scopio, Builder, and always forget the last one. Okay, so However, they can still work in unison, and you can still use the same Docker commands. So if we want to create an image, for example, we used in the past tense Docker build something. We can now do Podman build something. It actually, and if you on a Podman system say Docker build something, and you have installed the correct packages, it will underwater just translate your Docker to Podman and everything is fine again. So scripting wise, you should still be fine if you migrate from Docker to Podman. It took me a while, to be honest, to migrate from Docker to Podman, but I now love it. And the one thing I really love about it is that I need to elevate my privileges whenever I do something with Podman. In Docker, I needed to be root to work. I didn't need to be root to work. I had some ugly stuff working in the background that make it to work. In Podman, my security is better in order. But that's for me personally. Now, that's Docker and Podman. Now, Kubernetes and OpenShift. That's the other question, of course. What's the difference between Kubernetes and OpenShift? Actually, Kubernetes is a system whereby we can organize and deploy and administer containers. OpenShift is our Red Hat product whereby we take Kubernetes, the stock Kubernetes, and enhance it with some elements to make it enterprise. So it is 100% Kubernetes. You can even run your kubectl commands on an OpenShift cluster. However, your kubectl command doesn't have some features inside that the OC command does have because kubectl is not aware of the functionality of OpenShift. That's the only thing. So it is a one-on-one. And of course, with OpenShift, you have a platform which is supported. And this is very important to our enterprise customers. Now, how this works in our ecosystem, very simple. In the middle of our ecosystem, for us, lives Linux. No doubt about that. And then on Linux, we can do stuff. So we have enterprise Linux, of course. That's the version the distro we spit out for everybody. And on top of that, we can do things like put KVM on top of it. With KVM, we can do things like start using OpenStack. On OpenStack, we can install whatever is needed so we can run containers. Or we can run them directly on bare metal. So for us, the nucleus of the matter is Linux. And if you want to understand containers in the Linux landscape, you have to understand Linux. It is very difficult to create an effective container if you do not understand the underlying principles, as in the underlying operating system. If you do not know how to install Apache on a bare Linux machine, it is, you can perhaps create a container that does the same in a container, but you have no clue what you're doing, basically. And moving that even further down the road, going to Kubernetes, you have no idea what you're putting onto all your Kubernetes OpenShift nodes when you don't know what you build inside that thing anyway, because you don't know how to build a container. So the nucleus of everything here is what is Linux. So to wrap up, and then we'll go to, I promise we go to the better part, which is the demonstrations. What we put on top of Kubernetes in our OpenShift offering, our backbone, our Linux backbone is CoreOS. Our CoreOS is an immutable file system, operating system. An immutable operating system means you cannot change it. There is no yum install whatever. It's just not there. There are a few directories that can be that are writable, and the rest is read-only. And to be honest, you don't need to. It also means that your security, the footprint is a lot smaller. And your attack factors are a lot less because you have an immutable file system. Now, on top of this file system, we put plain Kubernetes. And plain Kubernetes runs as a container. So we have containers deploying containers. Yeah. Now, on top of all this, we put some extra elements, most in the form of customer resource definitions that for us makes it enterprise ready. So we put development tools on top of it. We put extra runtimes on top of it. We put extra monitoring and logging services on top of it. We put registry on top of it. So we make sure it is a complete product, a complete system you can install in your landscape and then start deploying applications on it or migrate your applications from your old infrastructure to this new landscape. If you have plain Kubernetes, there is a lot you still have to do before it is at the point where you can say, yeah, now I can deploy my application. One of the things, for example, is IDM. How do you use how do you manage your users? Out of the box, Kubernetes only accepts two users, kubeadmin and developer. That's it. Or actually only kubeadmin. So to have users in your system, you have to bolt on stuff. This is what we already done for you with OpenShift. Now, that's a lot of talk. That's a lot of stuff. Let's go back to the beginning. Let's go back to the place where we had that one big server, the one very expensive server, and we needed to install an application on it. And I am going to use, for this, my terminal. I like terminals. So in our first demonstration, by the way, is my screen readable for you? Please let me know in chat. Or do I need to make it a bit bigger? I don't have that many options here. Workable? Okay, cool. So, first scenario, install an application on your system. Now, the typical way we did that is with the script, the very simple script. Might be a bit bigger. I'm going to try, Martin. It is a bit. This is the best I can do. I have no clue where it's scrolling. So, installing a web server. Like I said, simple Apache web server. So on the Linux box, what we needed to do, and the people that have done their RHCSA or RHCE exams, especially when you've done it on 6 or 7, you might recognize this. Install HTTPD, enable, start, open up the firewall, take a web index page, throw it in the location where we need to go, make sure that the access rights and the ownership is set correctly. Start thing. Firewall, of course. So that's the oh boy. Yep. What happens when you do a demo? I'm of course not logged in as root. So I have to install everything by hand using sudo. Makes sense. Sudo install HTTP. Okay, done. Sudo systemctl enable D and start. We will get to why this is important in a bit in the next example. So firewall, sudo firewall. There's HTTP, HTTP, not HTTPD. This is not the daemon, this is the protocol. We know, of course. I'm not going to make it permanent. Yeah, good question, Frank. Why copy the index page after starting the app? And why not run the script as sudo? Well, because it's a demonstration. It's not, you're absolutely right, Frank. For a production environment, actually, I would put this in Ansible. Other discussion. I would never do this in a production environment. This is just to get you with the steps. And that should be it. I have a system that has been started. I've started it 2 times now. Just for good measures. Start it again. And now with a curl, I should be able to see my simple web page. Yeah. This is the web page for demo 1. Job done. Now this was the almost ugliest way of doing so at the time that we only had 1 box. And I assume now that this is a way you are familiar with. You know you have done this in the past. Can I have a quick shout of hands or something in the chat, please, that this is something you have done in the past? Doesn't have to be on Apache, can be on other applications, but you have installed applications on a Linux box in the past. Something in chat, please. Okay. I have to clean up my system now. System. Okay. No, too many times, yeah. So, yeah. Okay, cool. So this is this is something we know and perhaps well. Next step in the evolution was when the Docker came around in 2012, 2011, 2013, something around there. I saw my first glimpse of Docker as in, hey, now me as a developer, I can build my own web server. I don't need those people from the IT department again to create me a web server. I can build it myself on my local laptop, so I can build my applications. So I started at that time with Docker, together with Ansible, by the way. But so we started with that whole concept of having that thing we now created to build it on my local machine as a service in a box. So as a developer, I don't need to file a ticket to the IT system, get a web server somewhere in 3 weeks' time, and then I can start building my code on it. So Docker framework. And in Docker, what we need to do is we need to build that box of bits. We then, as one box of bits, give to our file system using that runtime, so it can run that as a service. And the first thing we need to do is we need to create that box of bits, and that box of bits is what we call an image. So an image is a file on the file system which contains your layered file systems, which we then give to a runtime. That runtime creates a container out of it. So a container runs in memory, an image lives on your hard disk. That's a very simple explanation. Now we need to create that image. The way we create that image is actually quite fun. Remember what we did in the first step. Yum install, copy a file, change the ownership. Sure, we don't have to do stuff with the firewall. We don't have to start the service, because that starting of the service, and we can debate if we need to use CMD or entry point here, but that's for another day. This is what makes this service, the service called HDBD, start as a foreground process within that container. Within that process, a process starts. This is all it takes. So what we need to do is just run that. Postman, build, that happens to be the command, build. I want to give it a name I understand. My web 2020 12 18 version 1. This is what we call the tag. And then I'm going to use the file called Dockerfile. Not nice. Don't repeat. Now for this, I need to put sudo in front of this. And before I do so, I may first prove to you that this image does not already exist on my system. So the way to do that is sudo podman show me the images. No image of that name exists on this system. So nothing in the left hand, nothing in the left sleeve, nothing in the right sleeve. It doesn't exist yet. Let's create one. And now it performs the same steps. It pulls now an image. Are there benefits for using the CentOS based compared to other maybe smaller base images? Yes, they are. And I'm going to refer, Dirk, can you please provide an answer for Frank?
Once again, where is the question?
The question is not in the Q&A, but in the chat.
Yeah, I'm just always looking in Q&A and there is nothing.
No, Frank put it in the chat. And yeah, while my container is building, can you?
Okay, I can answer it. I can answer it. Yeah, it makes sense. It makes sense to use a rel-based image. On registry reset.io, we have some. We have the so-called UBI images, the universal build images. They are very slim, but supported and always updated, patched images from Red Hat. So it makes sense to use Red Hat-based images, even if it's, let's say, a base image where you install or update your own software, because you will have always a supported image from Red Hat. Yeah, it makes sense.
Yes, and what I did not use in this example, and I should have used, was the UBI, like Dirk mentioned. We maintain them. We also make sure that they are updated and that they are security checked. As you can imagine, we are under attack. We keep being under attack. So also our containers and images are under attack. People find new ways to mess around with our images and everything inside that image. So sometimes we need to patch a UBI, and this is what we do. So if somebody found a way to compromise the ls command, for example, let's take a stupid example, then we will take steps in and to make sure that you have a safe version of the ls command inside that UBI. And we simply don't know what happens to the other providers of the images. Meanwhile, I see somebody in the Q&A that you copy the question. Frank, you copied your question to the Q&A. Okay, cool. Thank you. Now, meanwhile, I drank my coffee and my image has been built. And as you can see, it more or less did the same thing as what we did in the first step. It installed my Apache, it copied the file, it did the change mod, and now it provides me with a way to start this container image with this command. This is the command that is being executed when I run this container. So, with that part out of the way, that's this part, we can run it. We can simply run it using this. If you are familiar with Docker, wherever you read Podman, just replace it by Docker and you're good to go. Take it around, install Podman on your system. I highly recommend it because it has more functions at the moment than Docker. Replace all your Docker with Podman and happy to go. Sudo -d. I want to run it in the background. I'm going to give the name my web container 2020-12. Where are we? 18. I'm going to expose a port because I know in this case my internal container is looking at port 80 and I want to talk to port 80. Sorry, all the way around. I want to address this container with port 88. And then I'm going to give it a name. I'm going to look at the image I created. That's the one I'm looking for. And now, and that's this name. Awesome. It's done. And of course, put Podman in front of this because the run command on its own doesn't work. Now, that's very quick. Done. This is one of the great things about a container versus a virtual machine. And sometimes virtual machines are compared to containers. They are not the same. They're absolutely not the same. This is one of the main differences. We just start up a process which is very quick. instead of loading the operating system, getting all the stuff done, giving you a UI. Hey, I have a virtual machine. Now let's run the application. Can take you minutes. This is really like this. Sudo podman ps, which tells me, give me all the running images. I'm going to, and this is my running image. It's listening on my local machine on port 88. So I now should be able to talk to it. I'm going to use a very nifty command for this, because I need to use the IP address of my container. And I don't know what the IP address is. So I can ask the IP address for my container by using the inspect command. And then doing something cool like this, give me the IP address, and then use that as part of the curl command. So, look very fancy, it's not that complicated. Curl http -- I'm going to run a command in here. I should not have done this in this machine, so I'm going to do it a different way. Inspect. How did I call my web container today? My web container 2020 12/18. If I do this, I get a very long list of all the keys and values that Podman knows of on this container. I only need the IP address, so I'm going to narrow down what I need to know a bit by using this. Using this trick. It doesn't have my container. Why not? My web container, my web com. I am going to break this, my web container. Should be okay. Yeah, I think so, Frank. The thing is, if you use sudo, you're going into another security context. Yeah. Keep using sudo, Dick. Keep using sudo. So, IP address of my container. So there is an internal system in Podman and Docker that creates an IP address for every container. Remember the namespaces I talked about. One of the namespaces is the network namespace. The network namespace is what provides this IP address. And this IP address is only addressable for this host, this machine I'm on. When I'm on a second host and I create a pod or a container, it is very likely that it also will have the 1088.03 IP address. So when I have two hosts that both need to run a container, and those both containers together need to do something, it is very difficult to get a network established between those two hosts. So Docker, the solution we had, was a very good solution when you have only one host. When you have multiple hosts, you have to layer your networks basically. And this then becomes a very complicated piece of machinery very quickly. Yes, it can be done. I have done it. There's nothing funny about it. This is what Kubernetes solves, this networking part. But back to our little playground here, curl HTTP 10.88.03. And here is my second application. Look, demo 2. Yay, done. Now, yippee, I have a container running on my machine. But like I said, if I now need to have, how are we in time, by the way? Gary, how are we in the time?
Yeah, we're doing fine for time, Rick.
Okay, cool. When we now have multiple containers to run, and we need to have them to run on multiple hosts, multiple nodes, we need something to manage all those containers. Even worse, what happens if one of those containers dies? I have now, what? Yes, I have now a running container, but what now if something like this occurs? Somebody killed my container. Now, on a single host instance, this is a problem. Especially if you are reliant on this container. And this is where Kubernetes stepped in. Kubernetes is a platform whereby you make a contract to the platform and you say, hey, I have a very important container. This container needs to run always. Actually, it is so important to me, I need to run it at least 3 times. Make it happen, cluster. Then the cluster goes out, finds the hosts that have the capability of running your container, and sends out the instruction to those 3 hosts, hey, go and run these containers. So we now have a situation where our cluster is running 3 instances of this one container, and they are exactly the same. Now, if one of those containers dies, you had a contract with the cluster, remember. The cluster remembers this as well. So the cluster now takes actions to make sure that it can do good on its contract, as in, hey, we had an agreement, 3 containers is 3 containers. So it will find another host and then sends out the instruction, go and run this container. So I'm back at running 3 containers. Docker on its own cannot do this, period. Yes, you have all kinds of tooling that make some kind of things happen, but if you want to have a system that fixes it for you to abstract away that part whereby you can say, we have a contract and that's it, that's where Kubernetes starts. So now let's take this application and throw it on a cluster. No questions, no questions. Let's throw it on a cluster.
Yeah, it's a silent webinar, Rick.
It's a very silent webinar, yeah.
But maybe it's because in a few days we are celebrating the Silent Night, right? So this is maybe
entirely possible. Yeah, well. Okay, now remember, installing an application on one big machine, yum install, doing all the nifty stuff, and then you have it to run. Building a container, Podman build, and then you have the Docker file that tells you install this, and yay, we have our web server. Now we go to OpenShift or Kubernetes. This works in both instances. I'm running on OpenShift. Ibrahim, you are most welcome to also participate and chime in and talk. You're more than welcome to that. So some people in my classroom sometimes say everything to get him shut up. So just throw it out. I'm Dutch, I can have it. And we are in a small group, so This is a safe place to ask questions. The third step, and this is the step where we now say, don't take too much time on how the platform works, you as a developer. You have now a platform that helps you to deploy your application. You don't need to know what happens in the background. It says the event is live, you're in listener view and listening on. I don't know if you can switch on your microphone, to be honest, but you can put something in the Q&A, Ibrahim.
Yeah, there's no ability to chat, to talk, but the chat and the Q&A functions are there for any questions or any items you want to share with Rick or Dirk. Please do.
Yeah, or like what Frank did, when I make a typo, just throw it in. We have great courses for you, Martin, and we will come to this at the end. This is a lot. I truly understand this. What I hope to do is I hope to give you a spark, a little seed that next time you come up to this, you say, hey, I remember something like this. This has been told to me once before, and then you start absorbing it. This is too much to learn in 1 hour. It took me, if I take with me the whole Docker experience, 7 or 8 years. So, okay, OpenShift. OpenShift is really meant as a platform for developers. As in, you don't need to know what it's about, what it is, what it's about. You just need your workload, your application. Then we mix it together with the cluster, and you have your application deployed on the web, or on the internet, or on the whatever you export your application on. So, if we now go to what we need to do to get this same index.html to run. That's the big question now. So let's see what the setup tells us. Now, a lot of text, and I think I didn't tell you yet, but I'm going to tell you now. You should be able to see a repository here. Also for you, Martin, but for everybody of you. What I'm telling you now is something you can find on GitHub with the 3 demonstrations I'm now doing for you, and you can replay them yourself. This is a public repository. Feel free to throw in any suggestions if you say, well, I would like to see this, or maybe you could do this. It's there for you. To run these 3 workloads to see what happens. And what we do in OpenShift, we basically only tell it, hey, I have an application, and I created a beautiful application, in my case, an index page, and I have put it on GitHub. So, my dear cluster, take whatever I put on GitHub and make me an application. And the rest of it, choosing an operating system, installing Apache, setting up a firewall, doing that CMD stuff, I don't care. I just want my application. That's what this cluster does. So the only thing we need is to log into a cluster, create a project, and a project is a place where we can keep. I will come back to you, Frank, when I finish my sentence. The project is a place where we keep all the resources for this application. And on how you want to organize your cluster, you can say, well, I have all my production applications in the production project, and I have all my development stuff in the development project, etc. I won't do it. It's possible. You can, so it is your imagination how you want to divide the projects, and in the division of the projects, you can also limit the availability of the resources. So it's a great way of having the resources that make sense for one application, set applications to be connected together. Yeah, back to your question, Frank. Where can we find the repository? Exactly what Frank Muller said. It's that repository. You will always also get the slide deck we are using today, and in the slide deck you will also find the link. So I hope that will help you out there. So what we need to do is we need to create our new project and then tell the cluster to go and build us a project, an application. Now I need to log in, be logged in. I'll say who are me. Sometimes I don't have OC on. I have to switch to another screen for this. Not a problem. Also means I need to change my sharing a bit, because I cannot combine these two. Stop sharing. Yeah. Oh. This is interesting. I need some help here. Can you now see my?
Yeah, you're back. You're back.
Yeah, but can you see my terminal now?
Yes.
Yeah, you can see me type hello. Okay, cool.
Didn't see you type hello.
That's
the local host at Lenny page.
I'm still sharing on the wrong machine.
Yeah.
Can you hear us, Ray?
Sorry?
Can you hear me?
Yes, I can hear you.
Okay.
Because I now have a problem. It doesn't allow me to share the screen I want to share. Which means I have to make this more of a talk and see how we can get this to work in another way. So, I'm going to share this screen again, because you can see this web screen here. You can see me type hello here?
We do, yes.
Okay, cool. I have a small issue. Let's see if we can get this to fixed in another way. So back to my story, we have that set up. And in that setup, it tells us we need to create a project, and then we need to point to a certain repository to get our applications to run. Now, I hope you can see my OpenShift platform dashboard. Can you see this dashboard now?
We do, yeah. Yeah.
Okay. Now, I don't have feedback, or I don't see what I share. So let's run it this way. This is a little slower. That's why I don't really like this option, but since my other way is breaking up, we have to use this one. I need a project. I'm going to call this project Demo23. Display name will be Demo23, and the description will be This is a demo. Already exists. Let's see if we can use demo 23. There is 23. Be more patient. Now this is my namespace, and in this namespace I can start running workloads. And as you can see, there are no workloads at the moment. Because a workload would be something that runs in a pod. A pod is a construct for OpenShift. It's just a way to get, it's a way to organize container space. Now, let's get an application on this system using Git. My Git URL was http://github.com negens demos. I have a context directory I'm using demo3 files. This is where my index page lives. Git type, it's GitHub. And I'm going to use this one. Point and click, generate. That's an interesting one. This will take more time than we have, so I'm afraid I have to wrap up. Please check out my Git repository and do it for yourself. What now happens is it will pick up that index page from my Git repository. It will pick up the runtime image we already have for Apache. It will merge them together, and then my S2I tool, which is inside, knows that my index page needs to go to var.html. So it puts it in that directory. It creates a new image out of this, and this image then gets, from this image, a container gets created. And this is all with your hands in the air, or your hands down, or drinking coffee. You only need to push to point at, that's where my code lives. And it's an HTML, it's an Apache thingy, so get it done. As you can see, it's now running all the things it needs to run to get this to work. And I'm drinking coffee. This is what OpenShift brings to the game. Now we can even bring this further. I'm not going to do it today because my demonstration setup is broken down. If we change something in our repository, in our Git repository, so my Hello World page changes to Hello World Everybody page, we can set up this cluster in a way that it will automatically see, hey, there is a change. I will create a new image out of it, and I will publish the new application out of this image. And we can also have the whole testing in between. So your whole pipeline, your whole Jenkins pipeline can be in between this. Do we have questions? For now.
Nothing for now, Rick.
Okay, now in that case, I'm going back to the slide deck. So the traditional application, yum install, give it, tell it where the index page lives, and then it will be created. The real big drawback of this is this only works on my machine. If my colleague Dirk needs to create this page, he needs to have this index page on his local machine or somewhere we share data. The next iteration then is to do the same thing, but now using Docker. It has the same problems. It only works on my local machine.
So Rick, there is something just dropped in from Frank.
Yeah, I'll come to that question, Frank.
Wonderful.
Yeah. The place where we want to be is when we have a cluster and when we have the resources in a place that is shareable. So we want our application to be on a server, on a software version system, somewhere we all can access to. And then we can let the cluster create whatever we need to do because we made a deal with this cluster. I need 3 of these, get it done. I don't care how, get it done. That's basically OpenShift. Frank, your question, do you run the OC commands on the master or this is your client? Good question, Frank, thank you. You don't do anything on the master. You're not even logging into the master. Not on OpenShift 4. We sometimes did on OpenShift 3, but on OpenShift 4, all the nodes, especially the nodes that make up the masters, they are all on CoreOS. It's an operating system that is immutable. You do not log into your master. You use a client on another machine, in this case, my local machine. And with my OC command, I connect and I talk to the API server, which is exposed from my masters. But I never, ever log in to my master. So yes, OC is a client. Does this answer your question, Frank?
And there's one more from Frank also about mentioning, could you please quickly come back to how this works on a network layer when you have more than one instance?
Okay, please, how this works on a network layer when you have more than one instance, more than one instance of that container. You mean, Frank?
Rick, you saw the question from Frank?
Yes, but I'm trying to find out that we are talking to the same thing. If we're talking to more than one container running.
I've just answered yes on that one.
Yeah, okay, well, when that's the question, this is going back to, and we're now talking about running more than one container on an OpenShift cluster. What happens is the cluster will assign IP addresses to all those containers, and it will maintain the state of all those IP addresses. Actually, there is a separate service that maintains and keeps track of all the IP addresses. So you, as a carbon-based life form or another application, you don't need to keep a state of all the IP addresses. You just talk to a resource, the service resource, and ask that service resource, what's the current IP address of one of the containers that happen to have the workload I need to talk to? So if a container dies, if a pod dies, a new pod is spun up. That pod gets a new IP address, and that change is being managed by the service. So you talk to the service provides you with the IP address so you can talk to the pod or the container. Now, on a Docker environment, if you create more than one instance of an image, so you create more than one containers, the same thing happens more than one IP address. Every container gets its own IP address. And then you can have a lot of containers running on the same machine. They all share the same IP address, and typically they are capable of talking to their host. But you have to do other stuff to make them accessible from outside of the host. And you, from a network perspective, you have to create routes. And since you are talking about an IP address that is basically non-routable, it is an ugly mess. You have to use the overlay networking things to get this to work. Use Kubernetes or OpenShift, that problem is solved. You don't need to know what the IP address is. Does this answer your question, Frank? Kubernetes routes, it's according based to availability and loads. If we talk about routing, yeah, one of the things that you get basically out of the box using OpenShift Kubernetes is you get a load balancer. So if you have one container, traffic is routed to that one container. If you have 10 containers, a load balancer is basically taking care of making sure the load gets evenly distributed between the different containers. If one of the containers dies, container lives in the pod. Let's keep that part simple. If one of those pods dies, it gets replaced by another one. The services resource takes care of, make sure that the IP address is replaced, and the application has no knowledge that something changed in the background. It really makes sure that you can run close to 24/7. There are a lot of buts and ifs on this, but from a conceptual perspective, you can run 24/7, and you can have a contract with your cluster. Make sure it runs 24/7. Any other questions? No questions? Now, to wrap up, very quickly, what I did now, my first demo is basically what we teach you in the RH 124 and in the 294, which 294, of course, is the Ansible course, but mostly what we do in the in our Red Hat engineering track, we now have added Podman to the mix. So if you learn for your RHCSA, you have the RH 134 course. We talk about Podman, and what I showed you in my demo one is what you can take out of that one. The same goes for demo 2. We actually have a course called the 080, which is an introduction course. You can get it free of charge. Just sign up for it and do some exercises. It walks you through the steps to get that next step to done. The third one is what we cover in the 180 and 280 and the 288. That's why I say what I'm talking now in an hour's time is basically 3 courses, aka 12 to 15 days, just talking courses here. So Gary, with that, I want to hand it over to you to talk about the learning paths, and I can get some coffee.
Amazing, thank you, Rick. So yes, thanks for covering that. I'm going to cover now 2 learning paths, one for administrators and one for developers. So there's going to be some commonality in the 2 paths that you'll see as I go through them. And like Rick has mentioned, from what he's done in his demos, you'll see where those courses fit in to those particular demos and where you'll be able to pick up and learn those certain items through these courses that I'll go through with you. So for both streams, admin and developer, we would recommend that you look at DO080, which is a free course. You'll be able to pick that up from the Fastlane website and do that for free. Take you between 1 to 2 hours. It's video class, self-paced type e-learning that you can get access for 30 days. And you'll be able to just go through very similar concepts that Rick's covered here today yourself, as you know, your own pace, your own time, and when you feel is comfortable for you to do so. We all have busy lives, and with work and training is very difficult at the moment. But these resources are here, and what I want to go through with you is how we can help supplement that for you. So let's start there. DO080 free course, recommended, a good start for you to look into for your OpenShift journey. Second to that is another course that you'll find that is going to be in both paths, admin and developer, and this is the DO180. And that is, again, it's a recommended course that we suggest you do if you're looking to go through onto any advanced course, whether it be in administration or in development, and it's key for you learning foundation skills on containers and Kubernetes, especially around the Red Hat OpenShift. 3 days long, 4 days on virtual, and it's something that is key for us at Red Hat that you attend, or you look at the course that is coming up here, Administration 2, for you to be able to really get the most out of that course and be able to navigate and work through that course correctly. So from 080, 180 to 280, so that's intro, tech overview, your OpenShift 1, containers, Kubernetes, into OpenShift Administration 2, and that's where you'll create production and operating Kubernetes clusters within that. Now you can get certified and become a specialist in OpenShift administration at that point there. Okay, there's a course, an exam that is 3 hours long, and if you want to become certified, it's required you pass that. And we would certainly recommend doing the courses and learning the ways of doing things for you to be able to pass that exam. As with all our exams, they're practical, they're hands-on, scenario-based exams, and if you're looking to go straight into that exam without having done the training, you will struggle. The pass rates on that do define and show to us that training is key to be able to get certified in that area. So once you've done that exam and you've passed it, you think, well, okay, what's next? Okay, there is scaling Kubernetes and deployments within your enterprise, which is covered in the DO080. Okay, that's 4 days long, 5 days on virtual training, but that is your, a more advanced level of training of OpenShift administration, which is going to be certainly key if you're really taking your OpenShift platforms out to an enterprise. Next steps in there, and an item that Rick is really passionate about is the security side of things. And for this, Rick has told me many times that individuals must really have covered all of the courses, prior to it, the lead up, so the 180, 280, 380, to really get the most out of this particular course and be able to navigate through it successfully and also get certified. So it's a good journey to look at here, especially for you in your admins. All these courses are available through Fastlane. Work with the teams there on and any information, outlines, dates, etc. They'll be able to provide those to you. That's the admin path. Let's switch over to now what a development path would look like. And Rick, if you can go to those slides for me. Thank you. So what we have here again mirrors what I've just gone through with you. DO080 and DO180. Those two courses, great foundations, really recommended and needed for anyone doing their OpenShift journeys to really be your starting point. Now, if you're in the development side of things and you want to start being able to learn how to containerize your applications, OpenShift Development 2 is that next step after doing the DO180. And that's where you're going to learn all your development tasks and techniques in terms of building and containerizing your applications within OpenShift. Again, you can get certified in that, becomes, have that badge, being a certified specialist in OpenShift development, and that is a key point, and the milestone here that we have currently for you in your development paths. There are going to be some developers who are microservices based, Java functionalities, and will want to use those skills in looking at how they can manage microservices architectures. The course that really follows on and really goes into depth for microservices is the DO080. Again, we can look at that part there, and then following on from your development 2, you can look at the DO328, which again, takes on from your containerizing applications and maybe building resilient microservices with Istio and OpenShift service mesh at a real high level. There's a real, 2 real good journeys there for admins and developers. And again, obviously, speak to the guys at Fastlane on getting outlines, informations, and dates about those particular courses. So I just want to go over with you now what our learning options are. And Rick, we can get through to the ways to train slide. Thank you there. So at the moment, in the way the world is, we are doing all our live instructor-led training on a virtual platform. So Classroom at the moment is not available, and we're at least going to be seeing that until the summer. And so all our courses are still running, still have a good schedule of courses available, but we're just running them on a virtual platform. So you still get to interact with the instructor, you'll still have your manuals and so on, but the beauty is you can train from wherever you're located, having to travel, stay over, or visit a classroom. And that goes the same for an on-site delivery. And what we class as an on-site is a private on-site private event for you as a customer, for you and your organization only. So if you and your colleagues from the same organization need to have the training all together, we can still do that private event, even discuss with you some scoping and potentially some tailoring of content, or even making more modules focused to your business. Discussions with the likes of Rick and Dirk, we can do that and have that again as a closed event. We call it on site, and it will be delivered virtually. So self-paced options are there also if live virtual training during those office hours is not available to you, and weekend or evening learning is all you have available at the moment, but still need to get those skills. We have content from single class options, single method of deliveries for just maybe say the DO180 or the DO280. Or we have a repository that gives you unlimited access to all our training courses available from Red Hat, which is called a Red Hat Learning Subscription, RHLS for short. So individual course titles, you have access for 90 days. You'll get access to the content and the labs through that particular course. And again, through the RHLS, you get access to all the content, all the labs for a full year. And I'll go over that with you in the next couple of slides. So Red Hat Learning Subscription, as mentioned, there's 24/7 access globally, and it's available offline, self-paced, unlimited access to all the Red Hat courses, whether that be in a e-learning format, online learning as we've historically known it, computer-based training, or the more modern day way of self-paced learning via a video class. And that's more your YouTube style learning. And I have a full list of what each one means going through that. So you do get access to all the current content that's currently in development also. So beta content is always uploaded in there, so you can try and test, see what's coming in the future as well. And then as that content is updated and early releases come available, it's straight into that learning subscription. So you as a learning subscription user and subscriber will be first to market to get all the latest course information. And as I mentioned, there is content spanning the entire Red Hat product portfolio. So as Rick mentioned, within our enterprise Linux courses now, we do touch on Podman and the introduction to containers at a very early stage within system administration techniques. All those types of courses in there as well. So you can, enterprise Linux, Ansible, OpenShift, OpenStack, satellite courses, Our application development courses are in there as well. So there is a lot to really benefit from having a learning subscription. And once you've got those chapters completed and so on, and anything else comes available, you will be updated and have those access to them. So there are 3 different versions, and if we can come over to, here we go, this slide here, for our learning subscriptions. Okay, they're available through Fastlane, and we'll be able to, get information to you, links, do demos and so on through the team here. And if I just cover with you the different versions of what we've got here. So there's a basic version, which gives you access to the courses and the hands-on labs and some videos from Red Hat that you'd be able to just navigate through, watch and learn and listen to. And that is what a basic gives to you. So all your hands-on labs at 400 hours worth, access to all those courses I mentioned, whether it be e-learning or whether it be video courses, they're available in there. The standard version takes exactly that, but gives you a bit more of a benefit on top in terms of instructor office hours and certification exams being the 2 unique selling points for you going standard over a basic. And what do they mean? So instructor office hours is having that instructor on call to be able to help and support you with any issues, any troubles you're having with labs or you getting stuck. There's someone there to help you through. Starts off with chat. If you can't fix it over the chat, set up a one-to-one video call to get you through and navigate through and get you through to that next step of your course, and then off you go. And if you're looking to get certified, there are up to 7 exams available within a standard offering. That's 5 standard exams, so normal sits of an exam, and up to 2 resits should you need them. So in total, in a whole year, you could potentially sit 7 exams through a standard offering, which is great if you're really looking to get certified and have a good return of investment upon your training. Now, if you are a developer and you only want developer-only focused courses, there is a version called the RHLS Developer. It's about 14 courses, and it is just targeted on those development areas for you. So whether that be Java development, OpenShift development, they're all there. Again, you've got the learning paths, the video courses, the labs, and also 3 certification exams in there. So if you want to get that certification in that development side of things, it's available, it's there for you. So I have one more slide, and obviously I'm going to be sharing these, and essentially looking at that table there, you think, well, okay, what's a video class? What does instructor video mean? What are expert seminars? It's here, it's defined for you. You'll be able to look at these slides and think, okay, that's the benefit in what a learning path brings to me, what instructor office hours are, and it's all explained there. And again, reiterate, speak to the team at Fastlane. Gregory will go over how to do that next in his slide. And thank you so much for listening today and staying on to the session, having this information from us. We've really enjoyed being able to do this for you. And Gregory, over to you.
Thank you very much, Gary. Yes, as Gary mentioned, you can book all these courses at Fastlane. We deliver the official schedule in different time zones and languages, so even in English, German, French, Spanish, Italian, and so on. At the very moment, all our courses are instructor-led online courses due to COVID-19, but hopefully this is going to change summer next year. You can use your Red Hat training units also at Fastlane, and you will find, see here is a misspelling. You can register on flane.ch or flane.de, or if you're English speaking, then flane.ch/en or de/en. And I'd just like to make a little promotion for the next time. We will have the next webinar, free webinar, on the 14th of January. And we will send you these slides where this register here link will be enabled. And we will send you an email with the slides from today with the link to the next year's webinar. So thank you very much. Then over to Dirk for the Q&A.
Yes, I think we have answered all questions, as far as I can see. We had the question regarding the network stack, the commands of the master, or is this your client? We had the podman availability and the benefits of the rel base image. So I think all questions has been answered. Rick, right? I think there is no open question. If there is,
no, just,
I don't see in the event chat something as well.
Yeah, just updated that for Frank. Yes, Frank, that as Gregory mentioned, yeah, there was a small typo. We will update that before we send out the slides, and I've just put into the chat the correct website there. So please, obviously speak out to Gregory and his team there at Fastlane CH, or even the team in Germany there also, which you can contact through Gregory also. I'll reiterate a big thank you from us for your attendance. Thank you for the questions coming through. It helps with our delivery to have engagement and be able to speak with you around the items that are pressing for you. If there's nothing more, have a great Christmas and hopefully see you in the new year.
Well, thank you for me. Thank you for listening to me, and have a great Christmas and a great new year.